Good evening, everyone. Good evening, everyone. Myself, Anjali Ramashankar Prasad. I am a PMRF scholar at IIT ISM Dhanbad. So today we are going to start with the week 2 assignment discussion session on numerical methods. Course code is noc23-ma94, taught by Professor Amiya Kumar Nayak and Professor Sanjeev Kumar from IIT Roorkee. Okay, so let's wait for a few more minutes, 2-3 minutes to let join others, then we will start. Hope you have started solving week 2 assignment questions. So let's start. First question is, the reduced interval after performing the 3 iterations of bisection method for computing the root of e power x minus 2x square equals 0 with initial interval 1, 2 is, so you have to use the bisection method and find after 3 iterations what will be the interval in which you will get the root. Okay, and initial interval is given as 1, 2. So proceed using bisection method.
Is 1 and 1.125.
Okay, sir, let's others solve.
1 and 1.125 answer.
Okay.
You see.
Others, please proceed using bisection method and see in three iterations what interval you are getting. Is it the same? I hope you are solving it. Perform 3 iterations of bisection method and see what interval you are getting in which the root will write. So here we have f of x is equals minus 2x square plus e power x. Okay, so first iteration of bisection method we have to perform. So for that, what we need for bisection method, we find 2 points at which at one point we should get positive value of the function and at second point we should get negative value. Fine. So here we have been given the initial interval 1 comma 2. So for f of 1 you will get 0.7183, that is positive value, and for 2 you will get minus 0.6109, which is a negative value. Okay, so by bisection method there exists a root between f of 1 and f of 2. Fine. Now so we have shown that there exists root between 1 and 2. Now what will be x naught? For x naught we will take the mean of both the values, 1 plus 2 by 2. So we'll get 1.5. Now calculate the function value at x naught, that is f of 1.5. So you will get minus 2 cross 1.5 square plus e power 1.5. Okay, this will give you a negative value. Now we were having f of 1 that is positive and f of 2 that is negative. Now we have got 1.5 at which the function value is negative. So we will replace f of 2 by f of 1.5. That is the new interval that we get in first iteration, that is 1 to 1.5. Fine. Now for second iteration we will consider f of 1 and f of 1.5. Again the root will lie between 1 and 1.5. Okay. So see, are you following it? Check it. Are you getting it? If you have doubt in first iteration, let me know. So I hope you first iteration is clear to you. Now for second iteration, the root will lie in between 1 and 1.5. Okay. So again we are calculating the mean value, that is x1. that is 1 plus 1.5 by 2. So you'll get 1.25. So calculate the function value at 1.25. You will get 0.3653. That is a positive value. So now here at 1 we were getting function value as positive, and at 1.5 we were getting it as negative. Now we have got at 1.25 the value is positive. So we will replace 1 by 1.25. Fine. So in second iteration we have got two new values. At 1.25 we are getting function value as positive, and at 1.5 we are getting function value as negative. Okay, check it. Are you getting it? Similarly do for third iteration. So you will get, after 3 iteration you will finally get your interval in which the root will lie. Are you getting it for third iteration? Okay, done. So I hope you are getting it in third iteration. So here 1.25. So in second iteration we were getting 1.25 and 1.5. Now after third iteration we will get x2 as the mean value of 1.25 and 1.5, that is 1.375. Here you will get it as positive value at the function. So you will get 1.375. At 1.375 you will get positive value, and 1.5 you will get negative value. So by using bisection method, after 3 iterations, the value of your root will lie in between 1.375 and 1.5. Fine. I hope it's clear to everyone. So let's move to the next question. Okay. The second question is, a fixed point of the function g of x is equals x minus 1 whole square plus 1 is. So you have to find the fixed point of this given function g of x. Find it. So what is the answer? For finding the fixed point, you will take g of x is equals x. So you will get it as 2. Okay. Then you will substitute g of x equals x. So after solving this, x minus 1 whole square plus 1 equals x, you will get x equals 2. Fine. So correct option is C, that is 2. I hope you are getting it. Now let's move to the next question. So what is the order of convergence of regular false method? You might be knowing this answer. The order of convergence of regular falsy method. What is it?
1.61. 1.618.
Okay. So can you go through the method, how you are getting the order of convergence of regular falsy method? You know the process, right? How to calculate the rate of order of convergence. Okay. So in regular falsy method, by substituting xk equals xi plus xk plus 1 equals xi plus xk plus 1, and x naught equals xi plus epsilon naught. By substituting these values, you will get the order of convergence. Fine. So let's move to the next question. So here it is given that the question is the Newton-Raphson method formula for finding the root of a real number n power 1 by q using the equation x power q minus n equals 0 is. Okay, so you have to use the Newton-Raphson method and you have to calculate the root of the real number n power 1 by q by using this equation. Okay, calculate it. So have you calculated it? What's the answer? Just use Newton-Raphson method and put the values of the function. Take this x power q minus n equals 0 as function. Okay, what is the answer you're getting? Okay, so Ayush is saying that first option. Okay, so it's correct. So how will you proceed? For the equation you have been given as x power q minus n equals 0. So take x power q minus n as function value f of x. Okay, so according to that you will get f dash x as qx power q minus 1. Okay, so what is the Newton-Raphson method? Xk plus 1 is equals xk minus f of xk upon f dash of xk. Okay, so just substitute the value of f of xk and f dash xk. You will get these values x power q into x power qk minus n upon q times xk power q minus 1. Now multiply this denominator term over here. So we'll get it as q times xk power q. Now taking q minus 1 common, so we'll get q minus 1 times xk power q plus n upon q times xk power q minus 1. Okay, so you'll get it as option A. I hope everyone is getting it. If anyone has doubt, you can say. So got it? Shall we proceed? Have you got it? Everyone? If you have doubt, let me know. Are you doing it or shall we move? Okay, let's move to the next question. So question number 5 is, in which of the following intervals the function f of x equals x cube plus 4x square minus 10 has a real root? Okay, so you have been given 4 intervals, that is minus 1 to 0, then close interval 0 to 1, then close interval 1 to 2, and close interval 2 to 3. So you have to find among which of these intervals you are going to get this function value has a real root. So find it. So how will you proceed for this? Whenever you have to find the real root in particular interval, or you have to find how many real roots exist of the given function in intervals, in which interval, in all such questions you can use Strum sequence. Okay, so use Strum sequence and find it. Take this function value f of x and apply this trump sequence. By using that method, you can find how many real roots or in which interval you are going to get the real root. Solve it using trump sequence. For that, you'll take f of x value, then f dash of x value as f1x, then you'll find f2x by taking minus of remainder of f of x upon f1 f of x. In this way, you will find the sequence f1, f2 and all. So what is the answer you are getting? So You will get option C, the closed interval 1, 2. Are you getting it? Okay. So let's see how it's coming. So first of all, you will consider your polynomial, that is a cubic polynomial, as f of x. Okay, so here f of x is equals x cube plus 4x square minus 10. Fine. So this is your f of x. Now you will find f1 of x, that is f dash of x. So what will be f dash of x? 3x square plus 8x. Fine. So you will get f1x as 3x square plus 8x. Now you have to calculate f2 of x. So f2 of x is equals minus times remainder of f of x upon f1 of x. So now you have to find the remainder of f of x upon f1x. So find it using division method. So here it is our value of f1x, that is 3x square plus 8x, and here it is f of x, that is x cube plus 4x square minus 10. Okay, so when you divide it, so for first you will get it as x by 3, then next term in question it will be plus 4 by 9. So finally you will get remainder as minus 32x by 9 minus 10. Are you getting it? Remainder. Those who are still solving, just check it. Are you getting remainder as minus 32x by 9 minus 10? So once you will get this remainder, just put it over here. So you will get 32x by 9 plus 10. Now you have to calculate f3 of x. So what is f3 of x? That will be minus of remainder of f1x upon f2 of x. Fine. So now you have to calculate the remainder of f1x by f2x. So here we have written f1x, and here inside we have written f2x. f1 is nothing but this value 32x by 9 plus 10. Okay, so we put it over here. Now on dividing, you will get quotient value as 27 by 32 into x, and remainder as minus 7 by 16. Fine. So when you will put this, substitute with this value in f3 of x, so you will get 7 by 16. Are you getting it? Check it. Okay, if anyone has doubt in this values, how it's coming f1, f2 and f3, let me know. So once you are having f of x, f1 of x, f2 of x and f3 of x. Now you don't need to calculate f4x. In sum sequence method, we just calculate up to, we'll get a constant value. So now we are having a constant value, so you can stop over here. Now we will look over the table. Find the table. For table you have to write all the x values, that is interval values you have been given. So you were having minus 1, 0, 1, 2 and 3. Fine. Now first calculate the function value at this points, that is f of x value at this points. You just need the signs, what what sign you are getting. Either the function value is negative or positive. So when you will put -1, you will get -7. When you substitute 0, you will get -10. When you will substitute 1, you will get it as -5. When you will substitute 2, you will get it as 14. And when you substitute 3, you will get 53. Fine. So now you can see in whole these intervals, only this is the place where there is change in sign. So maybe root lies in between the interval 1 to 2. Okay, but it can be more also, like 0 to 2 also. It can be -1 to 2 also. It can be anything. So we need to find the interval in which the real root lies. Okay, so for that we will proceed further. Now calculate the value of f1x at all these given values: -1, 0, 1, 2 and 3. Okay, so when you will put -1, you will get it as -5. When you will substitute 0, you will get 0. When you will substitute 1, you will get f1x as 11. What is f1x? 3x square plus 8x. So just substitute these values of x. So at 2, you will get it as 28. At 3, you will get it as 51. Fine. Similarly, calculate the values at f2x. So f2x is 32x by 9 plus 10. So at -1, you will get positive value. Similarly, put at 0, you will get positive. Again at 1, 2 and 3, you will get positive value. Fine. Now f3x, as it is constant value 7 by 16. So all the terms at all the values, at all the points, you will get values as positive. Okay. So this is the table we have got. Now we will calculate the v of x, that is degree of freedom. For that, what we check is how many times there is change in sign in between fx, f1x, f2x and f3x. So here there is change in sign from f1 to f2 once. So we have written it over 1. Here, yeah, do you have any doubt? Do you have any doubt? Shall we move, or any doubts? So as we are here checking the change in sign, so here you can see there is minus, then there is 0. So here there is change in sign once. Now again there is no change in sign, so we'll get it as
Hello, ma'am.
Yeah. Yes, Ayush.
Yes, ma'am. Ma'am, for finding the interval, I have just used the basic method that we used to find the initial interval for the bisection method. Will that be an applicable for this sum, or will have to
No,
go through this process?
no. Actually, you can see here, if you will calculate at 0 and 2, then also you are getting the minus and positive value. Okay, you are talking about the options you have been given. So
Yes, ma'am.
actually,
Yes, I have.
yeah, you have used the method used for bisection method, but we use this method to find the interval in which we are getting real root. Okay, so you have got the interval 1 comma 2, but is it guaranteed that you are going to get over there real root? It can be complex root also, right? In the given options, luckily you are getting only one option, 1 comma 2. Fine. the options you have been given. So you are getting only one option where it satisfies the method as bisection method, but sometimes you will get 2 or 3 intervals in which they are satisfying, but maybe in one of the interval you will be getting only complex root. Okay, so here the question was in which interval you are going to get real root. So for that you need to use this method, Strum's method. Okay.
Okay, ma'am. Okay, ma'am.
So here now what is degree of freedom over here? So here you have minus, then positive. So here once it is changed, now next again positive, so only once the sign has changed, so you will get 1. Now for next, you see over here there is positive sign, then positive, then positive, then again positive, so there is no change in sign. So here you are getting no change in sign, none. So we'll write v of x as 0. Okay. Now in next, again positive, positive, positive and positive. So again there is no change in sign, so we'll write v of x as 0. Okay. So only where there is change, that is difference, write the differences. Here difference is 0, here difference is 0, here difference is 1, here difference is 0. So this difference implies that there exists a root, a real root in between these 2 points. Okay, that is in between 1 and 2 there exists one real root. If let if possible here it was 1, that will imply that in minus 1 and 0, in between minus and 1 and 0, you are getting one real root, but here it is 0, so here you are not getting a real root. Okay, so the only interval in which you are going to get real root is 1 comma 2, and if there might be other values also 1 1 1, then you will add it. So here 0 plus 0 plus 1 plus 0, it is 1. That is only one real root exists of this equation, and that is in interval 1 comma 2. Fine, I hope it's clear now. So this implies that function x cube plus 4x square minus 10 has one real root in interval 1 comma 2. You will by bisection method also you will get it as 1 comma 2, but it doesn't guarantees that you will get real root in this interval. For that we have done this. Okay. Is it clear now? Try it, solve it and check it. Are you getting all these points values or not? If you have doubt in any of the steps, let me know. Because whenever you will be asked to find the number of real roots, you will use this method. Using this differences, the values in difference, you will get the number of real roots, or also you can get the interval in which your real root lies. So this method is important. If there's doubt, let me know. Do carefully division and find the values at all the f values. Once done, let me know, or if you have doubt, tell me. you have doubt in any of these steps? Tell me. Are you solving it? Or shall we move to next question? Shall I explain the method again? Okay, tell me, shall I proceed or shall I explain this example again? Okay, let's move to the next question. I hope it's clear now. So next question is question number 6, that says the iteration formula for the fixed point method is xn plus 1 equals g of xn at n equals 0, 1, 2, dot dot dot, where n is the number of iterations and x naught is the initial guess. Okay, so consider the following two statements. First is the sequence xn is convergent. Second is the limit to which sequence xn converges is a fixed point of g of x. Okay, so these are the two statements. You have to choose one of the options. First option says that only first statement is true. Second option says that only second option is true. Next, C says that both 1 and 2 are true, and D option is neither 1 nor 2 is true. So tell me which option is true. Which of the statements is correct? So we have the iteration formula for fixed point with initial guess as x naught. Okay, so what does this mean? Does it mean that sequence xn will converge? And second option says that the limit to which sequence xn converges is fixed point to gx. Yeah, see. Which option is correct? Tell me. Are they both the statements are correct?
Yes, both 1 and 2 are true.
Yes. So both 1 and 2 are true. Okay. So in this fixed point iteration, xn is convergent sequence and it converges to the fixed point g of x. Fine. Now let's move to the next question. So correct option is C, both 1 and 2. Yes, this videos will be uploaded on YouTube. You can check it over there. The last week's video is also uploaded on YouTube. The link you have might be shared with you. This video will also be shared with you. So from that link or my YouTube channel, you will get these videos. Okay. So the video,
The video,
YouTube link I will share in the chat box.
YouTube link I will share in the chat box.
Okay. Just a minute. Just a minute, I'll share the next question. There is one issue. So question number 7 is, if the equation f of x equals 0 has the root x equals xi with multiplicity 2, okay, then the rate of convergence of the Newton-Raphson method in this case is, so you have given an equation f of x equals 0 and it has root x equals xi, its multiplicity is 2. So using Newton-Raphson method, you have to calculate the rate of convergence. So is it 1, 2, 1.6 or 1.68? Calculate it. What is the rate of convergence of the given equation?
Newton 2.
So I have shared the link for first video. From there you can access second video also. I'll upload it in 1 or 2 days or today itself. Okay, so we are saying answer as 2. So let's see how it's. So you will get order of convergence as 1. Okay. So how you are getting it? By Newton-Raphson method. What is the Newton-Raphson method? Xk plus 1 is equals xk minus f of xk upon f dash xk. Fine. Let's see it in an elaborate way. So this is a Newton-Raphson equation, and it has equation f of x equals 0 has a root x equals xi with multiplicity as 2. Okay, so we have root with multiplicity 2. Multiplicity 2 implies that f of xi will be 0 as xi is root, and f dash of xi will be also 0, right? Multiplicity of 2 implies that at f of xi you will get a value 0 and f dash of xi value will be also 0. Now substitute in this Newton-Raphson method. Xk is equals xi plus xk and xk plus xi plus epsilon k, and xk plus 1 as xi plus epsilon k plus 1. Okay. So when you will substitute on the LHS, you will get xi plus epsilon k plus 1 equals, on RHS you will get at xk you will put xi plus xk minus at f of xk you will get f of xi plus epsilon k upon f dash of xi plus epsilon k. Fine. Now this xi and xi will get cancelled out. Therefore epsilon k plus 1 is equals what? Epsilon k minus f of xi plus epsilon k upon f dash of xi plus epsilon k. Now apply Taylor series expansion on numerator and denominator, that is f of xi plus xk epsilon k upon f dash of xi plus epsilon k. Till this, do you have any doubt? Is it clear to everyone? Is it clear to everyone till this? Okay. Now apply Taylor series expansion. So you will get epsilon k plus 1 is equals epsilon k minus, here f of xi plus epsilon k you will expand, so you will get f of xi plus epsilon k times f dash xi plus epsilon k square by 2 times f double dash of xi plus epsilon k cube by 6 f triple dash of xi plus dot dot dot. Similarly in the denominator you will get f dash of xi plus epsilon k times f double dash of xi plus epsilon k square by 2 factorial into f triple dash of xi plus dot dot dot. Now as xi has x equals xi is the root of the equation with multiplicity 2, that implies f xi will be 0 and f dash of xi will be also 0. So substitute it as 0. So you will get epsilon k minus, this will become 0, this value will also become 0. Now you will get epsilon k square by 2 times f double dash of xi plus double dot dot dot. Similarly in denominator you will get this terms, f dash of xi will become 0. Now neglect the higher order terms, that is thrice and all, f triple dash and all these terms. So you will be only left with epsilon k plus 1 is equals epsilon k minus half times f double dash of xi upon f double dash of xi times epsilon k. Fine. So here f double dash of xi and f double dash of xi will get cancelled out. So you will get half times epsilon k. So by the method with which we find order of convergence, it says what? Modulus of epsilon k plus 1 equals some constant times epsilon k power p. That p gives you the order of convergence. So here the p value is 1. Therefore the order of convergence is 1. Okay. Hence, by Newton-Raphson method, for the given equation having root x equals xi with multiplicity 2, the order of convergence will be 1. Okay. So with respect to the multiplicity on all, the Newton-Raphson's method order of convergence will change. Fine. So I hope it's clear. Why is it 1 not 2? Just look into the method, the solution, and if you have any doubt, let me know. Or if it is clear, tell me. Just check the solution, try it. Do you have any doubt? Let me know. And if it is clear, we may proceed to the next question. Tell me. So in short, you can see over here, as the question was, the given equation f of x equals 0, having root x equals I with multiplicity 2, the rate of convergence, we have got it as 1. Okay. I hope it's clear. Shall we move to the next question? Okay. So next question is, consider the equation x square minus 6 equals 0 and x naught value at 2, that is initial value is 2. Then the value of x1 using Newton-Raphson iterations is. So you have given equation and initial value is 2. So you have to calculate the value of x1 using Newton-Raphson iteration. You can calculate it, it is easy. Proceed for it. So find out, is it 2.5, 1.5, 7.5 or 4.5? Find it and tell me the answer. So answer is 2.5. Yeah, it's correct. So correct option is A, that is 2.5. So how we are getting to it? Here f of x is equals x square minus 6. Now calculate f dash x, that is 2x, and the initial value x naught is equals 2. Okay, so for first iteration you will calculate the f of x naught value, that is f of 2. So after substituting 2 in f of x, you will get minus 2. Similarly, you will calculate f dash of x naught, that is f dash value at 2. So you will get it as 4. Fine. Now substitute it in the Newton-Raphson method iteration, first iteration. So x1 is equals x naught minus f of x naught upon f dash x naught. How are we getting it? So what is the equation? Xk plus 1 is equals xk minus f of xk upon f dash xk. So substituting all the values, you will get it as 2 minus minus 2 by 4. Therefore, you will get x1 is equals 2.5. Okay. So correct option is A. Is it clear? If you have any doubt, let me know. Is it clear to everyone? Shall we move to the next question?
Yes.
Okay. So question number 9 is, if the initial guesses are, that is the initial values you have been given, x naught as 3 and x1 as 4, then the value of x2 using secant method for computing the roots of x square minus 4 is. So if the function is x square minus 4, you have to calculate its root using secant method. And x0 is given as 3 and x1 is given as 4. You have to calculate its root, means you have to calculate the value of x2. So find it. Is it 2.2857, 5.5, 2.5 or 5.7143? Use secant method and find the value. Initial approximations have been given. x0 equals 3 and x1 equals 4. So using these initial values, you can calculate the value of x2. So what is the answer you're getting after first iteration? Tell me the answer, what you are getting after first iteration. Okay, let's check. Okay, so it's correct. Option A is correct. That is 2.2857. So how we are getting it? x0 is 3, x1 is 4. So calculate the f of, here f of x is x square minus 4. To calculate value of f of x0, that is f of 3, then you will put 3 at x. So you will get 9. 9 minus 4, that is 5. Similarly, at you will calculate the value of function at x1, that is f of 4. You will get it as 12. Okay. So now we have f of 3 and f of 4. So by using secant method, what is the formula? You will get x2 is equals x0 minus f of x0 times x1 minus x0 upon f of x1 minus f of x0. Okay, so just substitute all the values, x0 as 3, f of x0 as 5, x1 as 4 and f of x1 as 12. So you will get value 2.2857. Others who are trying, let me know if you have any doubt, or is it clear? Shall we move to the next question? Just check it. Are you getting it?
Yes, it is.
Okay, let's move to the next question. So question number 10 is, consider the system of equations. You have been given two equations, y square minus x cube equals 0, that is first equation, and second equation is cos y minus x is equals 0. So these are the two equations, and you have been given initial values as x0 equals 0.8 and y0 equals 0.7. Okay, so using this initial values, you have to calculate the next approximation x1 comma y1 using Newton-Raphson method. Fine. So I hope you understood the question. You have been given two equations in the system of equation. Take it as f of xy and take it as g of xy. You have two initial points, x0 as you have the initial point x0 as 0.8 and y0 as 0.7. You have to calculate the next approximation, that is next value at point x1 comma y1. Okay, so find it. Is it A 0.776 comma 0.6827, or B as 0.60 comma 0.776, or C as 0.745 comma 1.2, or D as 0.776 comma 0.082? Calculate it using Newton-Raphson method and let me know. You have to use Newton-Raphson method. Solve it using Newton-Raphson method and tell me the answer. So you will get the correct option as A. Check it, are you getting it? Consider f of xy equals y square minus x cube. That is first equation, you consider it as f of x comma y function, and second equation, that is cos y minus x, consider it as function g of x comma y. Okay, now calculate the partial derivative of f with respect to x. So you'll get it as minus 3x square, and calculating the partial derivative of g with respect to x, you will get it as minus 1. Similarly, when you will calculate the partial derivative of f with respect to y, you will get 2y, and then you will calculate partial derivative of g with respect to y. Here you will get minus sin y. Check it, are you getting it? Now, if it's been done, then you have to calculate the inverse of Jacobian matrix, that is JK inverse. So it will be given as 1 by dk, that is determinant at kth iteration, and here you will get minus sin yk and minus 2yk. Here you will get 1, here you will get minus 3xk square. Fine, as we are calculating inverse of the Jacobian matrix. Okay, so dk is 3xk square times sin yk plus 2 times yk. So by Newton-Raphson method, it's given as xk plus 1 and yk plus 1 is equals matrix of xk yk minus jk inverse times f of xk comma yk and g of xk comma yk. So just put here the values of x0 and y0 as 0.8 and 0.7. In the above equations, you will get it as 0.776 comma 0.6827. Okay. So this is one method with which you can proceed. Check, are you getting it? And I'll show you the next method by which you can get the answer easily. So another method you can follow for it is, Similarly, you have to calculate f of x, consider function f of x comma y as y square minus x cube and g of x comma y as cos y minus x. Here x naught equals 0.8 and y naught equals 0.7. Okay, so f naught value, that is value of f of x comma y at 0.8 and 0.7. So you will get minus 0.022. Similarly, calculate g of xy at x naught equals 0.8 and y naught equals 0.7. You will get minus 0.03516. Okay, calculate it. Then calculate the partial derivative of f with respect to x, with respect to y, and calculate partial derivative of g with respect to x and y. See, are you getting it? So when you will calculate partial derivative of f with respect to x, you will get minus 3x square. Fy you will get 2y, gx you will get minus 1, and gy you will get minus sin y. Now calculate the value of f of x, fx at x naught, y naught. Calculate the value of fy at y naught, and similarly gx at x naught and gy at y naught. Okay, so I hope you are getting these values: f naught, g naught, fx naught, fy naught, gx naught, and gy naught. Now you need to calculate the matrix D, that is determinant of fx naught, fy naught, gx naught, and gy naught. So calculate this determinant. Check, are you getting it as 2.636? Then calculate dx, matrix dx, that will be given by f naught, g naught, fy naught, and gy naught. Here you have to replace this column fx naught, gx naught by f naught and g naught. Substitute the values and check, are you getting it as 0.063396? Similarly, you will calculate dy, that is given by determinant of fx naught, f naught, gx naught, and g naught. Here in D matrix, you will replace the column, second column by f naught and g naught. In dx, we replaced first column, and in dy, we will replace second column. So I can substitute the values and check, are you getting it as 0.04550? So after you got d, dx, dy, so you can calculate h, that is given by minus dx by d. So you will get it as minus 0.02404. And k, that will be given by minus dy by d, that is minus 0.017258. Check, are you getting it, h and k? Now once you have got the values of h and k, you can find x1 and y1. So x1 is given by x0 plus h, that is, what was our x0? 0.8. So add h value into 0.8. So you will get, that is 0.8 minus 0.02404. You will get 0.77. And y1 you will get it as y0 plus k. So y0 was 0.7 plus k, that is y0, that is 0.7 minus 0.017258. So you will get 0.68274. Fine. So in this way you will get x1 and y1 as 0.775 and y1 as 0.68. That is option A. Fine. So by both the methods you can calculate the value. You will get the correct option as A. Fine. Just check your answer, and if you have any doubt, just let me know. Are you getting it, option A? I hope it's clear now. So today we have discussed 10 questions which will help you to solve the assignment 2 questions. Hope it helps, and if you have any doubt, so just let me know. You can put your doubts in the chat box, or you can simply turn off your mic and ask your doubts. And thank you for joining the session. I hope it helps to you. Any doubts from the questions we have discussed? Oh, So this slides will be shared to you, and also this lecture will be is being recorded, and it will be also uploaded on my YouTube channel. You can refer to it. The link will be shared to you. Already have shared the link of week 1, and the slides will also be shared with you. Okay, I'll paste the link again. So this is the link for first week session. On the same playlist you will get the second week session also. I'll upload it by today or tomorrow, and slides will be also shared to you. Yeah, the YouTube channel name is Anjali Prasad. Okay, you're welcome. Any other doubts regarding the session? So thank you for joining the session. I hope it will be helpful for you, and you can access these files to the link that is going to be shared to you, and also you can refer to the YouTube link, and this will help to solve you the questions. Okay, thank you for joining. Okay, so if you don't have any doubt, if you have any doubt, you can ask. I think it's fine. So let's end the meet today for here. And we'll meet in the next session. That will be on next Saturday, week 3. So let's meet next Saturday. It's fine. You can refer to the YouTube video or the slides that will be shared to you. Okay. Okay, fine. Thanks everyone for joining. So shall we End the meeting? Okay, thank you.